today we're going to do a demonstration on how to plan your flight with your eBee using SenseFly's eMotion Ag software. So this is our main welcome page. The first thing we're going to want to do is create a mission. You can title it anything you want, just to be able to find it later if you want to come back to it. You can just exit out of this disclaimer once you get onto the main page. So what you see here is we've preloaded our background map. This is the area that we're going to fly today. You can take a look in here. There's all kinds of different options that you can do. I like the Microsoft Hybrid, but definitely flip through them and see which one you like the best. The first thing we're going to do is cover our area of where we're going to be flying. So what this working area is a safety circle. Essentially it's going to keep the drone inside here and prevent a flyaway. So for whatever reason, if the drone gets out of here, it'll come back and land automatically. So now that we've put in our working area here, we're sitting in the office and we're connected to Wi-Fi, so we're going to want to download our map data. So you can hit that. I've already done it. It doesn't take very long to populate it. So now when you're out in the field, there's no requirement to have a cellular signal or any LTE or cellular data available. You have all this done already. So that's a nice feature of this program. So now we've put in our working area. The first thing we're going to do in this tab is kind of our takeoff and landing area. We're going to put in our takeoff. So when I'm flying this piece, I usually like to fly from this this oil field lease here. A nice spot. It's easy to drive out to. So we're going to place our start point here, our starting waypoint. What this is going to be is once we launch the drone, it's going to fly up to this. We can choose our altitude, adjust the longitude and latitude. Now when it comes to the altitude, this ATO, this is above takeoff. There you go, it pops up with the reference there. So the other two that you can choose are above the elevation data or above the mean sea level. But I like to use above takeoff just because it eliminates some of the errors. If you were in really uneven terrain, you might want to use something like above elevation data to prevent a crash. So now that we've done that, we're going to add our landing area. I usually like to land out on the field. I mean, it depends what stage the crop is in. Sometimes on the stubble, if it's canola stubble or something like that, it is quite hard on the drone. When you land, so you might want to land on the gravel here or find a grassy patch nearby. It's totally up to you. But for now, I'm just going to land out in the field just past where we are. So this is our landing area here. We like to give the drone as much option as we can. So what I've got is some obstacles here. There's the trees coming through here that I don't want. You can see it's going to be at 32 feet coming through the trees here, so that might be cutting it a little close. And we've also got this oil field stuff here. There's some towers and pumps, so we don't want to be at that 16 feet coming over there. So we're going to add our safety circle or our landing area there. That doesn't give us very much for options though, so what we can also do is add a secondary landing zone, and we're going to give it all this option as well because we should have no issues and no interference there. You can kind of check the altitudes as it's coming in and see, yes, it is good, we should be safe to land there. So now that we've got that set up, what the drone is going to do when it comes home to land is it's going to come and do a couple circles and figure out which way the wind direction is coming from, and then it'll land in the most into the wind direction as it can. So this is just like any airplane. You just want to be doing that so that your ground speed on landing is as low as possible to make it as gentle for the drone as you can. So now we've got our takeoff and landing point set. The next thing we're going to want to do is add our field where we're going to be flying from. So that'll be up in this tab here. We're going to add our field, new field. We can place it in the middle, and we just drag these corners to cover the whole field. Now this field's not a perfect square, so what we can do in this instance is we can actually add another point. So we just click on the line here, and it'll add an extra point for us. So we've highlighted our area. Alright, so we've done that, we've got our field highlighted. The next thing we want to do is adjust our resolution. So typically when I'm flying for ag purposes, just looking at crop health to make index maps and stuff like that, I'm going to be flying at the maximum altitude possible, which you can see at 4.3 inches per pixel is approximately 380-385 feet above the elevation data. If you want to fly lower to the ground and get a higher resolution, you can absolutely do that. You just bring this number down, but you can see as we come closer to the ground, we have to do more passes over top of the field, and our flight time increases drastically. So we can come right down to 1.5 inches per pixel, and that'll fly us about 140 feet, but it's going to take us almost an hour to do this quarter. So it's a huge time difference. So usually when I'm flying, for the sake of the demonstration here, we'll go right back up to 4.3. That's going to give us about 300 feet above the elevation data, which is close enough. We're allowed to legally fly, Transport Canada says we can fly at 400 feet. So that 380 gives us a nice little buffer just to stay underneath that. You can see our flight time is just under 20 minutes, which is really good for a full quarter section. Now I find that with my EBSQ, I can actually I can fly this piece and this piece up here all in one single flight with one battery, which is pretty cool. You can get a lot done in a day doing it that way. So that's the main stuff when it comes to planning our field. What's going to be there. You can also change your overlap. So if you want to have more overlap, again, you're going to increase your number of passes and increase the time that it's going to take you to cover your field. So usually 65 to 75% is what people like. The more overlap you have, the more accurate your data is going to be when it comes to processing after. So that's something to keep in mind. The last thing we're going to check, if you want to look at beforehand, is you can set your parameters. So all these are different safety things put in place to prevent your drone from flying away or getting lost or getting damaged. So if any of these things occur, the drone will come back to home and land. So if strong wind is detected, if there's something goes wrong with your camera, if the battery gets too low, if you lose connection to the computer for whatever reason, say your laptop dies or you accidentally unplug the modem or something like that, or if for some reason you lose your GPS signal, it'll all come home to land. This climb, if ground proximity is detected, so what that is if you have really uneven terrain, the drone has a ground sensor on it, so you can keep that on to prevent it running into the ground. So we should be ready to fly. I think we've got everything checked off the list here. We can just check our weather. Obviously you want to be doing a check in field to see if these weather predictions are right. I found that they're usually pretty close. We see that the wind is coming from 12 knots. Now this step I usually do in the field so I can get a really good idea of which direction the wind's coming from. But what we're going to do is we're going to adjust our flight direction to be as perpendicular to the wind as possible. So we should be pretty close there, I'm thinking, based on the arrow. And why we want to do that is because this will keep the drone flying at the same speed all the time. You think if you have it set to be going perfectly parallel to the wind direction, when it's coming into the wind, it's going to be working really, really, really hard. And it's going to be taking lots of pictures, and then when you turn around, it's going to have a really hard time keeping the drone speed above the drone's airspeed above the stall speed, and still taking pictures fast enough. Because think with the Sequoia camera, every time you take a picture, you're taking 5 photos, so it does. It can only take them so fast, right? So that's why you want to be flying as perpendicular to the wind as possible to give yourself the best data and results. So we should be good to go. At this point, if we're in the field, we would plug in our drone, hook up the battery, and hit this connect. And your drone will show up here so you can connect to it. But for the sake of this, it's a simulation, so we'll just use the simulator. There you go.
Pre-flight checks completed.
Our drone shows up here. This is our status. If you have any warnings or issues whatsoever, any calibration issues or something like that, it'll come up in the status. You can see the flights, the drone's battery level. It'll show the flight time counters are going, how far away you are from your launch, what your link quality is. This will be the estimated wind while you're in the air. All your other data, important instruments, temperatures, and then this camera information. So we're using the Sequoia camera on the eBee, which means we get two options for storage. So this is the storage right in the Sequoia, and this one is the external SD card that is plugged into the sunshine sensor. So you can use that. And then on the bottom here we have this artificial horizon. The artificial horizon just kind of gives you an idea of what the drone's doing in the air. It's pretty good, up to date. This is the heading of the drone. This is your airspeed in knots and your altitude in feet. This is above your takeoff level. So just some good information for you to take a look at while the drone is flying. Make sure everything's going good. What else we're going to do in here? So we've got the Sequoia camera. We can turn it on. And what we're going to do in this section, once the camera's on with the Sequoia, this is where you calibrate. So I like to do it before my flight so I don't forget. I find often after I walk out to get the drone and bring it back, and I forget to calibrate afterwards. So this is using that ground plate you set on the ground. You'll hit the calibrate button. It's going to give you 5 or 6 seconds to go stand above the target and position the drone, and it'll take the pictures and calibrate automatically. And then this is just some of your other options. This is the important one here, this manual control. So the Sequoia does come with a hand controller that you can use to move the drone. Like if in the event of an emergency, you can control the drone without using the computer. I would recommend leaving this assisted manual control on. The full manual control can be quite hard to fly, where this assisted manual control will only allow you to bank so far and climb so fast, so you prevent the drone from stalling or crashing. So we should be ready to go now. We've looked at everything. We're going to examine our surroundings, look for air traffic, stuff like that, and then we're going to launch. So when we're in the field, the launch is carried out automatically by the drone. You hold it sort of facing in front of you, shake it a few times, and the motor will start automatically. But for the purpose of the simulation, we're just going to hit this button here. This is going to be your launch button. It's going to tell us that the motor will start.
Caution. Motors will start spinning.
Okay, so now the props are going to start. It's going to do a couple checks. You can rock the drone back and forth to make sure the gyro and everything is working. And then when you're ready, you can throw it into the wind. Make sure you're always launching it into the wind. So here you can see this little triangle here. Now that it's launched, it's just climbing up to its up to the start point that we had previously set for it. You can see
going to start waypoint.
It climbed quite quickly to 260 feet. It is quite a steep angle of climb, so you can get over obstacles very, very well. So this triangle here, as I was saying, is a demonstration of your wind speed and direction. So the bigger the triangle, the higher your wind speed, and obviously the direction is where it's coming from. So today the wind speed, it appears that it's coming from the northeast, and you can see up here it's estimated about 5.7 knots. So we should be more than happy to fly at that. The drone should have no trouble. You can fly up to about 23 knots, which is quite gusty, to be perfectly honest. So anyways, we're up here, we're circling around, everything looks good, we're ready to go. Obviously we want to get to working on our field, so we're going to turn our field on.
Going to mission.
Now as soon as you turn the field on, the drone will automatically go. We're just going to speed it up here for the sake of the demonstration. So it's climbed now to that 380 feet, 390 feet, and it's going to begin taking pictures. So you'll be able to see as it goes, every time a picture is taken, it shows up on the software here. You'll actually be able to hear as your drone is flying overhead, the motor turns on and off. So every time the drone takes a photo, It actually shuts off the motor to prevent the vibration and get a clearer photo, which is quite a nice feature. It's not necessarily on every unit you can buy out there. So you can see we're pretty close on our wind speed. It's kind of crabbing into the wind a little bit, and the pictures are fairly even going in both directions, which means we got our wind direction pretty close to where we want to be. It doesn't have to be perfect, but definitely the closer you are, the better it is, the more efficiently you're going to do your flight. So at this point, you just want to be kind of monitoring things. Take a look at here, watch your temperatures, everything, your link quality and stuff like that. Keep an eye on your airspeed and your altitude, and you want to be keeping your eyes out for any air traffic in the area, any crop dusters or helicopters checking right-of-ways or anything like that. And just monitor your drone until the end of the flight. So I'm just going to speed up the video here just while it covers the rest of its flight. You can monitor the battery power as it comes. Usually I like to send it home if the battery gets down to about 25%. That's kind of pushing it. Any lower than that and you might be running into issues for sure, depending on how far away you are from your home point. Alright, so we're getting close to the end of our route here, flying the field. You can see it's been about 25 minutes flight time for our flying path. That's right from takeoff until now. You can see we still have 70% battery, so you know, it's still up here. Maybe we've got a little corner or something going on up here. At this point, if we want to, we can add another field. While we're in, we'll just make a little area here. We'll want to match sort of our similar direction. Our wind speed stayed pretty consistent, so we'll fly about the same, and we can turn this field on now when we're ready to go. So as soon as the drone has completed this one, it'll now go and fly this piece before it lands. We're not going to do that just for the sake of time here, but it's just something you can do, kind of monitor your battery. You can set this up previous to your flight as well if you want to do it that way. It's whatever works best for you. If you've got a couple little patches here and a couple little patches there, you can definitely do that. So we've taken a look. All our data looks good. You can see over the course of the flight, there we go. We've taken, this is what I'm looking for. We've taken 517 photos now so far, and that's times 5. Remember with the Sequoia. So using all 4 of the multispectral and the RGB as well. You can turn the cameras on and off in there in the settings here if you want to before the flight. You can go, you can change things here, what the settings are going to be. So just as it's coming down to land here, we'll just go over this top bar. These are evasive maneuvers. They're designed for if you're getting bird attacks or something like that. You can either do fast climb, a fast ascent, or a roll.
Going to home waypoint for landing.
A fast climb is actually the most effective. The most effective maneuver for a bird, because a bird can definitely dive. They'll dive after you. Or a roll, I mean, it might scare them off, but other than that, the fast climb is definitely the best option. So it's getting ready to land here. If this go to home, go to start, it would be in the middle of your flight. So it's getting ready to land. Say we want to hold for
aborting landing.
If something goes wrong in our flight, maybe a traffic or you see a car coming on or something that is going to be in your landing path or in your way, you can hit that abort landing and it'll just hold until you're ready to go again. You hit this go land. If for some reason you had something go wrong or you wanted to cover the field again, you can hit restart field here, or if you wanted to redo the mission at this point, you could hit this start mission and it'll go refly what you've already flown. So we'll just watch it come in for landing here. Sometimes you can zoom in just to get a better idea, but keep an eye on it. I usually like to keep my mouse over the abort landing button here in case anything does go wrong. You can see that it's chosen the path directly, most directly into the wind.
Landing now.
Here, which is perfect. The arrow's right along the line that's landing, and at 7 knots it should be very, very gentle.
$50, $40, $30, $20, $10.
So right at the bottom there, the drone will flare and come to a nice soft landing wherever you've chosen. I found it's usually pretty accurate. I can hit a tarp if I go set out a tarp in the field. You can land it pretty well right at your feet. You do, of course, want to be cautious when you're flying around obstacles. Say if you're on a yard site or something with bins or tall trees. You definitely want to be keeping an eye on that. So the first thing we're going to do now that we've landed, we go take our battery out, bring the drone back, and take everything apart and go home. Usually I like to do this next step in the office. This is our post-flight processing software. I'll do probably another video on this at a later time to show you how to process your software, but basically you take your pictures, it'll process them all, make the files up, and it'll be Pix4D ready for you, so you can open your project, write in Pix4D, and everything's ready to go for you to process. Create your index maps, your digital surface models, whatever you need. So thanks for watching. If you have any more questions, please go to the contact page on my website. That's hawkeyeag.com. Thanks for watching.